All right, section 3-2, simplifying algebraic expressions. And another way you could say this is combining like terms. All right, and we're on page 129. So there's a few terms that we want to be talking about here. And so these are vocabulary terms that are really important, right? So the first one is called terms, right? So we got to know what a term is. The first term in this is 2x. The next term is positive 8. The next one is positive x. And the last one is positive 8. So there are 4 terms here. Those are the 4 that you would list. Now, they're also called like terms. The ones that are alike, 2x and positive x are like terms, right? So you've got 2x and you've got another 1x. So those are like because they have an x. And then you have the other like terms are the positive 8 and the positive 8 because they don't have any letters at all. So those are also like terms. You have 2 different sets of similar terms. Then you've got the vocabulary word coefficient. And so coefficients are the number in front of a letter, right? The number that's multiplying, saying how many x's there are. There's 2 and there's 1. So those are both called coefficients. And then the last one is called constants. Constants are terms that don't have any letters at all. It's just the plus 8 and the plus 8. Those are called constants. All right, so as we move forward through the year, just knowing those vocabulary terms will be really helpful. It'll come up over and over and over through different things that we do. And example 1 here on page 130, it says 3x minus 4x plus y minus 2. Let's list all of these things out. The terms, we're going to list those. Terms are 3x, negative 4x, y is a term, and negative 2 is a term. Then we have like terms. All right, so like terms, I'm sorry, that's not a negative 3, just 3x and negative 4x. So those are a pair. I would circle those together. Y is its own by itself because there's no other terms that have a y. And then negative 2 is also its own term. It's a constant. There's no other terms that are just numbers. All right, and then you've got coefficients, right? Coefficients are the number in front of the letter. So there's a 3 in front of x. There's a negative 4 in front of x. And then there's also in front of the plus y, there's a 1 there. So the coefficients are 3, negative 4, and 1. And then we've got the constants. The constants are, there's only one constant, and it is negative 2. All right, so just knowing that going forward, again, will be really helpful as we do things. All right, example 2a, we have 6n plus 3 plus 2n. And again, we're combining like terms here. It says to simplify the algebraic expressions. That means to simplify or combine like terms. So here I'm putting rectangles around the first term, and then I always do that. I just put a rectangle around the very first one, and then rectangles around everything that's like with it. So we have 6 ninjas plus 2 ninjas. That is 8 ninjas. And then we've got a plus 3 as a constant that's just sitting there. So that goes down by itself. You don't put those together. Those are not like terms. So 8n plus 3, or you could have 3 plus 8n, and then there's 2 more ways you could write these with double signs that we've talked about in class. Example 2b, we have 3x minus 5 minus 8x plus 6. So again, I start with the first term, put a rectangle, and I rectangle everything else that is alike. So here we have 3x minus 8x. That's what that says. The minus sign has to go with the 8. That's important. So basically that says go right 3, and then minus 8 says go left 8. So right 3, left 8, you end up at negative 5. And of course there's an x involved. Then the other terms are negative 5 plus 6. So that would be left 5, right 6. You end at positive 1. All right, those are not like terms, so you can't put them together, but we can flip this around, keep the 1 positive, keep a negative or a minus in front of the 5. 1 minus 5x. Example 2c. Now this combines a couple things, all right? So we're always using PEMDAS, even when there's letters involved. So we start with parentheses. It says n minus 4m. Those are not like terms, so we're not going to put those together. So we move on to E, exponents. There are none. So we move on to multiply, divide. And here's the multiplication, right? So there's a 3 that's multiplying by the parentheses. So I'm going to go ahead and do what's called the distributive property. So I'm going to take this positive 3 and multiply it by n. Positive 3 times n is plus 3n. Then I'm going to take positive 3 and multiply by positive 4m, and I end up with positive 12m. Alright, so now I'm on a step. I can put a 1 in front of this m. Now I can combine like terms. So 1m plus 12m is 13m, and then I've got a plus 3n. That's not alike with the m, so it drops down. Again, you can commutative property that, flip it around, 3n plus 13m is another way you can write that one. Last example here, number 3, says suppose your brother has 15 more baseball cards in his collection than you have. Write an expression in simplest form that represents the total number of cards in both collections. So what we're going to do here is, it's kind of weird, but we don't know how many you or your brother have. But what we do know is we can say you have X amount of cards, right, since we don't know. And then your brother has what you have plus an extra 15, right, because he has 15 more. And the question is saying how many total cards are there. So to get the total cards, you would just add how many you have plus how many he has, which in this case ends up being this weird little expression. You're adding your amount, and then you're adding his amount. So if you add all those together, this is where we combine like terms. I mean, it's really pretty simple after that. This is a pretty easy one. You end up adding your like terms together, and you get 2x plus 15. That is the total number of cards. All right, so that's the end of section 3-2. Guys, best of luck. Ask any questions that you need to. It doesn't make sense.